Bernoulli's principle. And so, Bernoulli's principle. Bernoulli, back in the 1700s, came up with this idea, and it holds true today. It's a principle of physics that basically has to do with why airplanes and birds, really, that's what he was looking at, are able to fly. And what it states has to do with lift. So this is a cross section of an airplane wing. The portion on the top of the wing, this part right here, the top of the wing, is longer than the bottom. The bottom is shorter distance than the top. So if we took a measurement from right there to right there, that distance on the top is longer than the distance on the bottom. The plane, of course, is moving in this direction, and the air is flowing, and it's cutting through the air like so. And if we looked at a molecule, at two molecules really, we looked at two molecules. One molecule is right here, and another is right here. The one on the top is going to go over the top along the longer side of the plane, and the one on the bottom is going to go along the shorter distance underneath the wing. So the molecule that travels along the top goes a greater distance, but it does so in the same amount of time as the one on the bottom, and they both end up at the back of the wing at the same time. That means if they arrive at the same time, that means that the one on top is faster, because it's going a greater distance in the same amount of time. That means that the one on the bottom is slower than the one on the top. Okay, we good up to this point? Well, good old Bernoulli, he said that the faster the fluid is, the lesser the pressure. Okay, the faster the fluid, the less the pressure. So if I were to draw a vector that represented the forces, first of all, let me write in the pressures. So faster means less pressure. So on top is less pressure. And on the bottom is more pressure relative to the top. So if I were to draw a vector now that represented those forces, the vector pointing coming from the bottom would be greater than the vector from the top. So I'm going to draw a bigger arrow on bottom and a smaller arrow here on top, just to visually represent that. So because the pressure on the bottom is greater and the pressure on the top is less, that creates something that we call lift. Lift. Meaning that if you push this wing through the air with a propeller, or pull it through the air with a propeller, or push it through the air with a jet engine, it's going to create lift for every molecule that goes over the top. One goes down over the bottom, down under the bottom. The ones on the top are moving faster because they have a longer distance to travel. Because they move faster, they have lower pressure. Because the pressure on the bottom is greater, it pushes up on the bottom of the wing relative to the top. And that's something in aeronautics we call lift. And it holds true for birds as well as it does for an airplane. Whether the airplane is a good paper airplane or a 747 or whatever. Or a bird. If you look at a bird's wing, the next time you see a seagull on the beach dead or just flying around, I mean, you could take a close look at their wing, and their wing looks literally like this. Yeah, don't touch dead birds. Leave that to me. All right.
Ooh, you're filming.
Yay.
Hi, people from the other class.